So today we're going to start off in chapter 2, and in chapter 2 we start talking about proofs and how to write proofs. And basically, for today's lesson, we're going to talk about inductive and deductive reasoning. Inductive reasoning is using a number of cases to arrive at a specific conclusion. Your conjecture is the statement that you're making based on using inductive reasoning. Alright, so for today, our first few problems, you're going to be writing a conjecture about this pattern that they give you right here. So notice if we look at A, anytime they're increasing numbers, you're either going to be multiplying or you're going to be adding. And right here, to get from 2 to 4, of course, they multiplied it by 2. To get from 4 to 12, they multiplied it times 3. And if you were to guess yes, it would be true, for so on and so on. So they want us to make a conjecture, basically give us a sentence of what the next term would be. So obviously they're going to take 240 and multiply it times 6, and that's going to give us 1,440, okay? So our statement, our conjecture would be that if we were to use this pattern where they were multiplying by 2, 3, 4, 5, and then now 6, our next number in our series would be 1,440. Okay? Alright, moving on to the next one. Example 2. It says, make a conjecture about the sum of any odd number and an even number. Okay? An odd number and an even number. And the sum, so we're adding them together. So if I add 1 plus 2, I've got an odd number and an even number. That's going to give me 3, correct? If I add 2 plus 3, here again I've got an even number and an odd number. That's going to give me 5. If I were to keep going, let me do one more. So if I said 3 plus 4, that's going to give me 7. Okay? Notice, it says make a conjecture about, to support my answer here. They want us to notice, is there any sort of pattern that we see here? And notice that every time we add an odd number and an even number, we wind up getting an odd number. So our conjecture would be the sum of any odd number and even number is odd. Okay? And if you keep going, of course, that would be true. If I wanted to, I could try some really big numbers, 102 plus 103. Well, that's going to give me 205, and 205 is still an odd number, okay? Just give yourself a few just so that you can come up with some sort of a pattern to write a conjecture for, okay? All right, so the next thing I want to talk about is negation. Negation is finding the opposite of an original statement, okay? So, for example, here's our little symbol. What I want you to think about negation is the word not, okay? Today is Monday, so the negation would be today is not Monday, okay? If someone said, I do not like candy, the negation would be, I do like candy. So if you're writing the negation, you're either including the word not or taking it out, okay? All right, so now we're going to get into some sentence structure, okay? A conditional statement is a statement that can be written in the if-then form. And basically, the if-then form says, like, if today is Monday, then tomorrow is Tuesday, okay? The if-then form would be written like this, okay? The P, what we call, is the hypothesis, and that's anything after immediately following the word if, okay? The conclusion, which we call as Q, would be anything that would immediately follow the word then. So let me give you an example here, okay? Identify the hypothesis and conclusion. So here's the sentence, if a polygon has 6 sides, then it is a hexagon. So anything immediately following the if is going to be the hypothesis, okay? The conclusion is everything after the word then, okay? After the word then would be your conclusion, sorry. In our next sentence, it says, Tamika will advance to the next level of play if she completes the maze in her computer game. In this one, the definition of hypothesis and conclusion is true. Everything after the word if is still going to be the hypothesis. Okay? And then, of course, anything else after that, after the word then, would be the conclusion. Okay? All right. Let's go ahead and go down here. It says, identify the hypothesis and conclusion, and then write the statement in the if-then form. So measured distance is positive. And for this one, I said if a distance is measured, okay? So this would be my P part, or my hypothesis. And positive would be my Q, or my conclusion. My P and Q. Okay, so I would say if a distance is measured, then it will be positive. Okay, so there's my sentence stated in the if-then form. And here you can, of course, see the hypothesis and conclusion. Okay? Last thing, it says, determine the truth value for the conditional statement. If false, give a counterexample. So A says, if you subtract a whole number from another whole number, whole numbers are going to be anything after 0, 0, 1, 2, anything that you can count, that would be a whole number. So it says, if you subtract a whole number from another whole number, then the result is also a whole number. So let me take 3 and subtract 5. If I take 3 and I subtract 5, that's going to give me -2. If I take 1 and I subtract 2, that's going to give me -1. If I subtract 6 and I subtract it from 2, that's going to give me 4, okay? The answer says that the result will also be a whole number, okay? I gave 3 different examples here. This one happened to be true where it was a whole number. But notice right here where I gave some examples, these numbers that are negative are not whole numbers. They're actually integers, okay? So because I found, and all you need is one example, because I found a counterexample, then guess what? This statement is false, okay? And the way it would be false is if you had a whole number and you subtracted a bigger whole number, you would get a negative number, okay? So it is false because we found a counterexample.